Hello, ladies and gentlemen. I'm going to walk you through how to solve a few different types of exponential equations in addition to kind of introducing you into solving log equations as well. So if you look at your note sheet, this is where we left off last week. And the first thing that you should hopefully notice is that the x is in the exponent, which for us means that we're always trying to get that x down to the normal level to be able to solve for it. So the first things that we're going to want to do in this particular problem is to divide by 4 to both sides of the equation. You have a 10 raised to the 3x, that is equal to a 5. And now you'll notice that the x is still on the left-hand side, it's still in the exponent. So our goal is to try to move that down. The only way that we know how to do that is to take the log of 10 to both sides of the equation. Because when we do that, on the left-hand side, some things are going to cancel out as we go through. And we notice the log base 10 and the 10 will cancel out. So all we have is a 3x. On the other side of the equation, we have a log base 10 of 5. And now, since that exponent was brought down, we can solve for x. We divide both sides by 3. And now in this case, we have to make sure we know how to put this into our calculator. So there's really two different ways that we want to put this into our calculator. All right. If you have the log base function, this works out pretty nice. So I know it's a regular log, but I do just want to show you how this is. You would put the 10 in the bottom. You would put the 5 next to it. And honestly, what I would recommend doing is pressing the enter sign right away and then divide that answer actually by 3. Okay. If you don't have that log function, what you have to do is just type a regular log and then whatever is next to the base, so log 5, divided by your log 10. You should still get the same answer after you divide by 3, either way. So depending if you have the log base function like this first, makes your problem a bit easier to solve, or if you don't have the log base button, that is what you're going to have to do where your base is always in your denominator as you're solving. So now the other key thing here, again, I won't be picky about rounding with your final answers, but you do have to make sure that you do not put an equal sign. It is an approximate for your final answer. Right? Now, as we look at the next question, these are, I think, harder than any log question you're going to see because these bases are completely different. You have a log base 5 and a log base 7. So if you remember, when we did our notes prior and we had to make a decision here about which base to choose, our base here, we said that we want to get rid of the more complex side. That's always what our goal actually is, get rid of the more complex side. So in terms of logs, a base of 5 and a base of 7 really aren't any more complicated than one another. So we look at the exponents, and this x plus 2 is a little bit more complex than the x. So what we want to do is take a log base 5 of 5 raised to the x plus 2 equals our log base 5 of 7 raised to the x. And now we are able to get rid of the more complicated part so that all we're left with is that x plus 2, the part that was in the exponent. On the other side of the equation, we still have our log base 5 of 7, but friendly reminder, our log properties say that we can take something that's in the exponent and bring it on down so that we have an x directly in front. And now our goal is to get here the x by itself. The bad news is there's more than one x. So in this case, we need to get the x's on the same side of the equation. So right now, well, let's subtract an x from both sides. We end up with a 2 then, that is equal to an x, log base 5 of 7, and then we have a minus x at the very end. Now just be careful with this because the x times the log base 5 of 7, that's all tied together. Okay, so really, this is no different than saying you have a 3x minus x, except for the fact we can't combine these like terms right away. So what we would do, we would take an x out of this situation and have something left. So in that case, that means on this right-hand side, we take an x out, and we have our log base 5 of 7, and then at the very end, we have still that minus 1. that would be equal to a 2. And as we continue to go now, this x is almost all by itself, so we can actually divide this log base 5 of 7 minus 1 to both sides of the equation. That's just a number. It might seem a little bit complex, but it's just a number. That's all that this actually is. So what we need to do is put this into our calculators now and make sure that we know how to put this into our calculator to get your final answer. So what I would recommend doing, I'm going to clear out what I have here, is, again, you can do this a few different ways. We have a 2 that's being divided by, and use your parentheses. That's going to be an important piece of information here. So if we notice, the next thing that we have is the log base 5 of 7. So we go into our math, we find that log base button, and we have our log base 5 of 7. Now the key here is that the minus 1 is not with the log. So you have to press arrow over, so you're outside of the log, put a subtract 1 on there, and end your parentheses. So be really careful, because it's very easy to make a calculator mistake on this type of a problem. And now you get a 9.56 approximately. That is your final answer. So we end up then with an x that's approximately equal to our 9.56 as what our final answer would be. Okay, so that's a few more examples about properties that are talking about exponents and an exponential form. So now, if you look at the bottom of your note sheet, we're going to look at problems that have logs, right? And as you're looking through this, when you just have one log in the problem, like the example that you see on the screen, this you're probably already going to solve. Because if you have one log, the first thing that you want to do is to change it into exponential form. So that means you have a base of 2, that would be equal, 2 raised to the x, which in this case is 8, so 2 to the 8th power is equal to a 2x plus 4. And now, as we're trying to solve this into its most simplified form, I'll let you take a second and actually get x to find out what it's equal to, because the nice part about this is you're going to come up with a regular old answer. Nothing different about anything you have here. That regular old answer should be 126. So you did your step number 1, change into exponential form. Step number 2, you solved just like a regular problem. And then this is the key here. You have to check for an extraneous solution. So anytime you start with a log, okay, there's certain things about logs that we know. If we're thinking about the domain of any log function before transformations, your domain is 0 to infinity. So what that means is we can't have negative numbers after and we do all the transformations. So that's why we need to check for extraneous solutions. So you need to plug this in. So our step number 3 is our check step. In this case, when we put our answer that we got back into the equation, where you see an x, the left side should equal the right side. So yes, we need to check every single log equation that you have. So we have a log with a base 2, and then what we have inside the parentheses here is a 2 times 126 added with 4 ends up being a 256 inside of the parentheses. So now what you can do is you can plug this into your calculator to see if the log base 2 of 256 is actually equal to 8. So if we go here, log base, button in my calculator, I put a 2 here, I put a 256 here, and it does equal 8. So we know that, in fact, this does work out. So all is good. We don't have to change our answer. We know that 126 would be our final answer, right? Now, properties change a little bit because now we have more than one log. You see the logs are the same, which is good news. They're both log base 2s. But in this case, we need to make sure that all of the logs are on the same side of the equation. So on the right-hand side, you see we have a negative log base 2 of 27. That's just a number, so we can add it to both sides of our equation. So when we do that, we have our 3 log base 2 of x added with log base 2 of 27, which is then just equal to a big fat 0 on the right side of the equation. And now there's a really nice song that we'll start to sing a little bit each time that we're solving logs, because now we have 2 logs. So after you have two logs that are both on the same side of the equation, these two logs are going to become one log. So our song says 2 log become 1. So in this case, well, you see the plus sign that you have between these logs, which means the 1 log we're going to write still is a log base 2. And since there's a plus sign, it means you're multiplying. The one thing we can't forget is that this 3 that's in front can really come up top and make that into an x to the third. So when we multiply those together, it's no different than saying you have 27 x to the third. That would be equal to 0. Right? So now we've created our 2 logs to become 1. Well, this now is exactly like the problem that you did in your last example, because 1 log is going to, in some way, shape, or form, become change. So you change forms. 2 to the 0 is equal to a 27 x to the third. So our 2 logs become 1 log. 1 log becomes change because we change the forms. And after that, next thing we do is solve. And as we solve, we wind up with a 1 that's equal to a 27 x to the third divided by 27 divided by 27. We end up with a 1 over 27 that's equal to an x to the third. And now we cube root both the top and bottom number, and we get an x that's equal to a 1/3. So now our last step, we still have to check our answers. All right, so I'll let you put this in, make sure the left side is equal to the right side when you put a 1/3 in. Hopefully you paused the video, stopped it, checked it, and found out that it does work. So our song then is 2 logs become 1, 1 log becomes change, change becomes solve, and solve becomes check. It's the steps that we would do as we're trying to go through a problem. All right? So then the last problem for your video today is going to be a log base 4 of x plus log base 4 of x minus 3 is equal to a 1. So right away we see that the logs are on the same side. We notice there's 2 logs. So that means 2 logs become 1. The 1, if you notice here, has a plus sign in the middle. So we have to do a little multiplication. So that means we have an x times an x minus 3. And you might be wondering right now, well, are we going to have to multiply those together? Okay. Our goal is to solve for x. So more than likely, you are going to have to solve and simplify, and in this case, multiply these 2 pieces together. But in this case, our 1 log now becomes change. So 4 to the first, and then I'm going to multiply these 2 pieces together so that I have an x squared minus 3x. I continue to go with trying to simplify this and know that I have a 4 on the other side. And since now, in this case, we have an x squared and we have a regular x in this problem, that means we have to factor, right? That factoring means that all the terms have to be on the same side of the equation. So we end up with an x squared minus 3x minus 4. And hopefully the factoring method that you notice right away is your x method. So we have a negative 4 on top. You have a negative 3 on the bottom. The 2 numbers that multiply to the negative 4 and add to a negative 3 are negative 4 and 1. So if we're trying to go to our next step, we know that this is x minus 4. We know that this is x plus 1. And now, since both of these parentheses have to be equal to 0, we end up with an x equals 4 and an x equals a negative 1. So our 2 logs became 1. Our 1 log becomes change. Our change becomes solve. And our solve now will lead to check. I'll give you a second to check this over. I will say that 4 works. Negative 1 should not work as you are checking this over. The only answer for this problem should be x equals 4. So your goal for tomorrow is to start the front side of the worksheet. If you have questions, bring them to class tomorrow.